We're going over a final exam review topic for Nova Online Math 161, and this one looks like graphing quadratic function using transformation. Graph the function, state the domain and range. So we have f of x equals negative 1 over 4 times x minus 3 squared plus 2. Let's talk about the transformation over here. So that minus 3 inside the parenthesis, this will shift the graph right 3 units. And that adding 2 will shift our vertex up 2 units. So using that much, I'm going to go ahead and plot the vertex first, okay? So the goal is to graph these. So xy axis, I'm going to go right 3, 1, 2, 3, and go up 2. And here's my vertex. And I like to draw the axis of symmetry in the middle. So the graph, I'm going to try a parabola that is symmetric about that line at x equals 3. Okay, the axis of symmetry is always going through the x-axis, x coordinate of the vertex. Okay, I need some point to the right and left of this. Okay, so for that, let's plug in some numbers. Okay, want to make xy axis, and I really think they never said how many points to plot, right? So I think just 3 points will do. Okay, I'm gonna have right in the middle our vertex 3, 2. Now I do want to have another point to the right of it and to the left of it. Now we can really plug in any number if we want. We really can. But think about this for me. After subtracting and squaring it, we will have to multiply that number by 1/4. Okay, negative 1/4. So it will be better if we can try to make the number to be a multiple of 4 inside, so we can divide it by 4. Does that make sense? So there's no wrong answer here, but we can pick certain numbers that will look better on our graph. Okay, so here is a suggestion, and I'm really just thinking about this right now. How about we pick 5? Look, what will happen if I pick 5 and plug it in here? Okay, let's see if that gives us a nice number. Okay, let me erase some of these writings here. This is where I need to plug in 5 and 2. And guys, you could have plugged in 4 if you want. Okay, I just decided to plug in 5 because I feel like if I do, I may get a nicer number out. So let me try that. Okay, so that will give me negative 1 over 4 times 5 minus 3 squared plus 2. Now, let's see what happens. I'm going to get negative 1 over 4 times 2 squared plus 4. You see where I was going with this, right? So I'm doing negative 1 over 4 times what? 4 plus 2. Now, negative 1 over 4 times 4 is negative 1. And if I add 2 to that, I will get 1 out. So I picked 5 because I knew that subtracting 5 minus 3 will give me 2, and 2 squared is 4. And I thought that that will work nicely by when I multiply it by negative 1 over 4. So when you plug in 5 into the function, you will get 1 out. Now watch this, okay, because I really don't have to plug in another number, okay? Using that axis of symmetry idea, hold on. I'm going to go plot 5, 1 first, okay? So 1, 2, 3, 4, 5, plot 1 right there. But axis of symmetry is telling us that if I have a point that is 2 to the right from that axis of symmetry, I better have another point 2 to the left from that axis of symmetry on the same horizontal line. So if I have that red dot over here, 2 to the right of the axis of symmetry, I better have the same point 2 to the left from the axis of symmetry. So, and you know, if you are taking an exam and if you want to double check if this number will work, definitely plug in the value of 1 into the function. And you'll see, if you plug in 1 into the function, I guarantee you will get 1 out. Okay? And that is just us using the axis of symmetry idea, okay? Now, I think 3 points enough. I'm just going to go ahead and sketch a very wide parabola. And notice it's going down. Why do you think this is going down instead of opening up? That negative leading coefficient, right? And this is definitely wider than our typical parabola because of this factor of 1 over 4. So it made it that much wider, okay? The closer these numbers are to 0, the wider the graph will be, okay? So now let's do the last part. They want us to find the domain and range of this quadratic function. Domain of any quadratic function is always going to be all real, okay? There's no restriction on what kind of number can be squared, okay? So the domain is all real, but range we have to be careful. We can see that this is going down forever. So I'm going to say negative infinity. But what's the highest point of this graph? Well, the highest point of this graph is at y-coordinate of the vertex, which is 2. But very common mistake that I see when I'm grading these exams is that they like to put parentheses. But no, we do have a point that touches the y value of 2. So you must put a square bracket after 2. And that's it for this problem. We graph the parabola. I just picked 3 points, but you can do more points to make it more accurate. But we also stated the domain and range of this quadratic function.